Well, hey there. My name is Brandon Rhodes. My contribution to the conference will be a talk. I call it Forcing a Unit Test to Function. Let's tackle an example problem. When I check out a small package that has 0 runtime dependencies, I'd like to be able to run its tests with 0 testing dependencies. For a big, heavyweight project that already has dependencies of its own, sure, I expect a heavyweight setup, creating a virtual environment and installing its requirements.txt. Might as well use a third-party testing framework. I can list it right in requirements.txt itself. But for a small little package I'm writing with 0 dependencies, I'd like to be able to develop on it with 0 install. Now, Python's old motto was batteries included. And sure enough, the Python standard library does include a testing framework named unittest, though it was originally underpowered. So third-party testing frameworks full of features became popular. But unit tests started to quietly improve around Python 3.2. It got a fail fast option. If there was a failure, it showed it to you immediately without you having to wait for the whole rest of the test suite to run. A option to buffer standard out and error, very popular in third-party modules. And it got test discovery. What do I mean? Well, let's create a little example package. It's a single line long. It's dunderInit.py, just has a comment that says a simple package. Because the interesting thing about this package will be its tests. Create another file, package tests.py, that builds a unit test tests class that has 2 test methods inside of it, creatively named test1 and test2. What I mean when I say unit test doesn't have test discovery is that if I say python-im unit test, running the unit test module, package doesn't find the tests. Unit test forced you to list every module on the command line. You had to say package.tests for that module to be loaded and its tests run. If you had 3 test modules, you had to list all 3. It was tedious. Test discovery fixes this. The new feature meant that you could say unit test discover, and it would go find your packages, your modules, and your tests automatically. Test discovery made unit test nearly usable. And it's pretty fast. Unit test runs our tiny test.py pretty quickly, 0.1 seconds on my laptop. By contrast, a leading third-party testing framework takes 0.8 seconds on my laptop to do the same thing. Given the common advice that all unit tests combined should run in 1 second, a testing framework that takes 0.8 seconds to just get up and running doesn't leave my tests with much time left. But unit test has a big remaining problem. It makes you write tests as ugly methods rather than as beautiful functions. Which means we have to import a class we don't want, build a subclass that we don't like, and lose 4 columns of precious screen real estate to useless indentation just to get 2 simple tests written. It's raised a question in my mind. Could my own package add this missing feature to unit test dynamically and on the fly, and let me start using unit test again and throw frameworks overboard? Well, the answer, of course, is this is Python. We can do anything. So I refined the question to, can I add test function support in a way that is simple and elegant enough that I'm willing to use it and carry it in my small projects in their code? To answer, I had to stop thinking about it and actually try. So, to review how unit test works, how does it find tests? The answer is through Python's powers of introspection. Most Python programmers know how to access the items in a list or a dict. But how do we loop over the names in a namespace, like a module or a class? Python allows that through a pair of built-ins, one called dir, probably named after the old DOS command that listed the files in a directory, and getattr, get attribute. Going back to our example module, we can see that it imports test case and then defines a single thing, a class called tests. If in example.py we from package import that module tests and run dir on it, will we see those names? Well, it turns out yes, and several other names besides. Python secretly adds a number of dunder names in every single module in order to keep up with their metadata and keep up with extra information about them. But you can see there at the beginning of the list, test case and tests, both things imported from outside and things defined in the module, are available in that namespace. After learning a name from dir, we can get its object, get the thing it refers to, with getattr. So now we're pivoting example.py to just a single getattr call on tests to try to look up a name that we've just listed as a string, test case. Will the object come back and be printed? Yes. So those are the two steps, the two abilities, dir and getattr. They are an elegant part of Python's design. Some of the older dynamic languages offered only eval as the only way to introspect. You had to eval the string tests dot and then append the name to make a full expression, tests dot test case or whatever. This was slow because you had to every single time parse and compile and run a new expression in the language that you'd just written. Overpowered because this can not only do name lookup, it can run any arbitrary Python expression, and thus dangerous if an opponent or someone controlling your input could turn name into a full Python expression that does insecure operations. So instead of forcing you to call eval, Python offers a clean, limited, and dynamic operator for each fundamental namespace operation. Where in code you might say a.b, or assign to a.b, or del a.b, Python offers a corresponding built-in that performs the same limited operation, but with the name specified dynamically instead of as a literal in your code. What steps, then, does unit test follow when looking for tests in a module? Well, the unit test contract, if we want to call it that, is that it first collects test case classes. We saw it do that before, though we didn't know how. Then, if it's there, it will call a function that you define called load tests. You can peek inside of unit test's code, it's written in plain Python, to see how it works. In unit test loader, this is what it does to find classes. For name in, and it runs dir on your module, it getattrs each name and checks if it's a subclass of test case. Simple enough. In then defined methods, it runs dir on your test case class, and for each attribute that starts with test, it gets it with getAttribute. Again, simple enough. Dir and getattr. Then I will admit things get weird, but it was the 1990s, Java was popular, and unit test was based on JUnit, Java's testing framework. Unit test instantiates your test class n times, once for each test method that it found. Isn't that weird? You'd think a test class would just run all of its methods, but no. You have to instantiate it once for each method. This is easier to show than to describe, so here's our test module again. Test 1 and test 2 inside of a class called tests. And here are exactly the steps that unit test will perform. But now I'm doing them manually in example.py without asking unit test to do them. It first instantiates two test cases. It instantiates two instances of the tests class, one naming the first method and one naming the second method. It puts those in a test suite, which is a collection of tests, and submits them to a test runner. We're now going to run this example.py, and the unit test logic will all run without unit test being directly invoked. Python example.py, and it found, well, it didn't find, we gave it, and ran our two tests. So that's how unit test normally loads tests from test case methods. But there's also an escape hatch. After building the test suite, unit test does one last check. It says, getAttr module load tests, just to see if it's there. If load tests is defined, then unit test calls it. Here's how that looks. The signature is a little complicated. We'll only pay attention to the middle argument, suite. Load tests gets the suite of tests discovered so far, can add or remove tests from it, and then return it. Here, for example, is how to add a test to the suite. If I toss a third test into my test class that's misnamed, so it won't get discovered, division doesn't start with the word test, then unit test discover won't find it. But if I write a load tests function, I can manually add that method to the test suite and see it run. That's what load tests lets you do. Add in whatever tests you want without following any rules. The standard library doctest documentation, for example, recommends this exact mechanism for adding doc tests to your package's test suite. It gives this little example where you define load tests, suite.addTests, and you instantiate a doc test suite that it defines for you that will deliver all of your doc tests packaged up for unit tests to run. So, if we want unit tests to load our test functions, which remember was the goal here, we have two chances to do it. Because the contract has two parts. It collects classes and it calls load tests. So we have a design decision. Which mechanism should we use for enrolling test functions? Let's code both solutions. Instead of just thinking about it, let's try it out and use that experience to help us decide. So these are our two options. We can build a test case class, or we can define load tests and do it there. We'll tackle them in that order. All right, we are now pivoting to the kind of tests I want to write. Simple functions up at the module level. And per its barbarous practices, unit test refuses to find them, recognize them, or run them. How should we get ourselves started? Where should I start writing some code? Well, let's do API-driven development. Let's write a call to an API that we wish existed, and then we'll see if we can make it exist. All right, I imagine that I need, at the bottom here, a class named tests, but I don't want to build it. I want someone else to build it. So let's imagine that I call find tests, that through some magic finds these tests. I could just import that from a module called utils, and the secret code that does discovery wouldn't need to live here and clutter up my tests.py. I think that's a decent API. I think it has a good chance of working. So next, let's try implementing this API. Package utils.py. I just promised myself I would write it by trying to import it, and it'll obviously need a find tests function. All right, what can we put here to build a tests class that will convince unit tests to run our little functions? I am going to use what, for me to have good velocity, is an essential technique: hard coding. I'm going to write exactly the code that's needed for this one specific case, so we reach working proof of concept as quickly as possible. So, shamelessly, because I know the name of my tests module, I'm just going to say from package import tests, because I know that one of its tests is called test1. I'm going to have a tests class with a method called tests1 that calls my function tests1. And then I return that new class. Is it ugly? Yes. Is it case-specific? Yes. But I just want to see if it works. And it works! Woohoo! Party! That's why I love hard coding. Now that the code works, I can iterate quickly towards a full solution, enjoying working code at every step. Let's iterate. Obviously, I now need to do two things to turn this code into a real solution. I need to make dynamic how it finds the module, finds the tests, and how it adds the tests to the class. None of that can be hard-coded when I'm done. All right, so let's tackle that last thing first, how it adds tests to the class. I won't be able to write the methods as literals. Instead, I'm going to have to attach them one by one. So let's grab the test function. I will call it f. I probably just can't assign it to become the method test1. I don't think. No, test1 takes 0 positional arguments, but 1 was given. I've seen that before. What did we do wrong? Always commit working code once you have it to version control, so you know exactly what changed when you break something. Thanks to the fact that I did that, I can back up and look back at my previous working code. And with that error in mind, I now see that, of course, the method takes 1 argument, self, and the function takes 0. So the function cannot just stand in as the method. Can't simply be installed as a method. So we need a wrapper. You might have done something like this before, defining a wrapper that's going to return a method. So it takes a function that takes no arguments and returns a method that will accept self without crashing. So now, over here, I don't assign a raw function, but rather a wrapped version of the function to the .test1 attribute of the tests class. That should intercept the self parameter and not raise an error. And it works. We now know the syntax for installing a method at runtime. Success! We now can check off that first of the 3, or final of the 3 tasks. Now, it turns out that wrap that I just wrote should look very familiar. It's already a Python built-in. That concept is called static method, so I don't need to define it myself. I can just use static method to wrap the test function, and that will make sure that self is not supplied as an argument where it doesn't belong. Does pivoting to static method work? Yes, it does. So I'm now happy we've reduced the amount of code needed for this third step. Now let's do the middle one, how it finds the tests. All right, right now we are just installing a single test that we've hard-coded. Now we need to pivot to the kind of maneuver we saw unit test doing before. We're going to run dir on our tests module for name in dir tests. If the name starts with test, then we can't get it by a hard-coded name. We have to use getAttr to fetch it. And because we don't know what the method will be named either, we need setAttr to create that. But we're still using static method to wrap test functions so they become test methods. And it works. So we now have accomplished our middle step. Finally, we now need to make dynamic how it finds the module. How does find tests know which module to look in? And that raised an interesting question. How do you find the module? Well, there's actually several ways it could do this of varying degrees of magic. The way I thought of it is, where do modules live? They live in the sys.modules dictionary. You need only their name to get them back out. So if we knew the module's name, we could retrieve it, the module, from sysmodules. It would look like this. We know the name somehow, still hard-coding it, module equals sys.modules, and dictionary lookup of the module name. That works. I just now need to figure out how to give find tests the module's name. Well, I'm going to have to adjust the API so it's passed in, because it'll be different for every module. This is unfortunate. I had such a simple API, you just called find tests and magic happened. Well, no more. We're now going to be passing manually the name of the current module so that it can be introspected. It will come in, module name will, as an argument. And it works. We now have made the solution fully dynamic, and we now know what it looks like to build a custom test case class for every module full of test functions. It takes 10 lines of code, plus that one extra line per module that you have to put at the bottom. That looks like this, and is somewhat succinct, if a little bit dundery. Let's now turn to the other big alternative. Once again, I'm going to do API-driven design. This time, roughing out what the API will look like, I'm going to, in addition to the tests I have in my module, define an official load tests function that takes a test suite and returns a test suite. All right, just like for the dot test case, I'm going to call add tests on something. Clearly, I need something like a function that discovers my tests and returns them. So let's have it be imported from a utils module and call it find tests. And this sounds familiar enough that I'm even going to go ahead and guess that I should plan ahead to pass it the name of the module. Time to write a new utils.py module. Let's again start by hard coding the test to quickly reach a working solution. So it looks like this. I grab the module from sys.modules. I just hard code a tests class with a test method that calls my test function just like before, because I'm just trying to see if this idea works. Difference is, rather than returning the entire class, I instantiate it first because that's the contract that's made with the find tests function. And it worked. I successfully, for the first time ever, have created a test class instance myself, and it worked. I can celebrate that I now have working code, working proof of concept. I'm now off and running with a second solution. I know it's going to work. Now I just need to write the code. Now we enjoy the luxury of iterating on a working solution. Let's make the class now fully generic. So I took a few dead ends in trying to do this, but I'll give you the short version in the interests of time. First, we're going to pop the hard-coded function name out so that instead of the test having it hard-coded inside, it's relying on the scope around it to know which function is supposed to be called by the method. Does that work? Yes, it does. All right, now that the test method is just calling a generic test function f, there's no reason to give it the name test1 of the test anymore. We can just call it test. And when we instantiate the test class, we just pass it the string test every single time. And that works because the name matches the method. Next, if we're always just going to call the method test and not have it vary with every single different test function, then we no longer need to pass the string test as an argument. We can hide it inside of the init, and it can take care of talking to test case and giving it the string that it needs. Does that work? Yes. Finally, instead of having the test function f found because it exists out in the enclosing scope, we can instead treat this like a real normal class and pass in all the data it needs. We will pass into test module.test1 and have it remember the function it's supposed to call. And that all works. Over that little series of refactorings, we've achieved something big. Test can now live outside of find tests. We don't have to spin up 10 different copies of this class if we have 10 different modules. The same class can just get used over and over again, each time wrapping a different test function. And it works. Then I noticed something. I'd been looking through unit tests code as I wrote the talk, and you know this tests class that I just took several minutes to write? Yeah, it already exists. Way down at the bottom of unit test is something called a function test case. It's way down at the bottom of the docs as well. I'd never realized its significance. It's exactly what I just wrote, but integrates even better and it names the module better in the test output. I went to all that work to write a class that I now get to throw away because there already is one. So we can use the built-in function test case. And I did all of that work to produce 3 lines of code. Well, we now are successfully submitting this test function as an object to be run as a test. And so now we can just drag in the dynamic stuff we did before. Look up the module, create an empty list of tests for each name in the module if it starts with test, get it with getAttr, and this time we build a function test case of that function and append it to the tests. Thank goodness we did that earlier solution. Made it much quicker this time. And now all of our test functions are being discovered. Party. We now know that the second option is quite easily codable as well. It requires 10 lines of code that I'll carry along in my package, plus 3 lines of code per module, because all of them will now have this little function at the bottom of every single test module. Verdict: I can do either of these. I choose the second one, based on the fact that I now have working code that I can compare. I choose the load test function. Yeah, it's 3 lines of code per test module, but it's explicit rather than implicit. I mean, you can see the name, add tests, right in its code. Even a newcomer will have a guess as to what it does. It uses a standard unit test feature instead of the crazy idea of building a custom class at runtime. It creates only instances at runtime, not classes, and it composes well with the doc test instructions or any other documentation that might have other kinds of tests that a user needs to add to their load tests function. A quick aside. I know that many of you are right now ready to scream, but what about asserts? I'm sure you have that question, but what about the asserts? Because you noticed me quietly pivot without mentioning it from using assert equal in my tests to plain assert. I did it quietly, but I had to do it because we don't have self anymore once we have a test function. How do we get pretty asserts back? If you don't have self, in other words, how do we call self.assert equal? The answer is Python's pre-bound method pattern, as made famous by modules like the random module. What you can do is this. In your project, make a little asserts.py module. Import test case. Instantiate a throwaway instance of test case. And then bind each of its useful methods to a global function name. You get to turn methods into functions through the act of binding. Then you can, in your test module, say from asserts, import assert equal, and use it as often as you want. That's my approach, at least, when I don't want a third-party package like my assert rewriter that's on PyPI. End of aside. Time to summarize with a few takeaways. I hope that you got a little glimpse, if you hadn't seen it before, of how easily Python introspection works and how to use introspection in developer tools. I hope you saw how hard-coded solutions let us start fast with very literal code and iterate. How prototypes help us decide between approaches. I often try to think, what approach do I want to take, and solve it by just thinking about it. Writing a little code often makes the difference more clear. And of course, in case you're ever curious, you now know how to plug test functions into unit test if you ever want to. Again, my name is Brandon Rhodes. My only regret is that I'm not able to be there in person with you today. Stay safe. I look forward to the day when a Ukraine victory has established peace within the entirety of its internationally recognized borders. Stay safe, y'all.
Brandon, hello.
Hello.
How are you?
Doing pretty well.
I
Got up very early to start listening to the talks in the track, but I'm still awake.
yeah. What is the time you have right now?
7:50 a.m. in the
Oh
morning.
wow, I'm amazed. I just wanted to say that we really appreciate that you support Ukraine, and Ukrainian community appreciate that you found time and shared your knowledge and experience with us. Thank you for the talk and your presentation, and thanks for joining us today. And for now, I don't see. No, actually, I have a question. Is your new testing framework something you are planning to use from now on? If you can, please answer your question. Answer this question.
So my assert. So in small projects, I am planning to use the code that I just demonstrated. I'm already doing so in one or two of my small Leaf projects. Have no dependencies in my astronomy library. I am planning to use my assert rewriter in projects where I don't mind having test dependencies. And in my main Skyfield library, I actually use, much to the annoyance of the Ubuntu people that have to package it, I use my own testing framework entirely, which does my own assert rewriting. So at each level, both what I demonstrated in the talk and then what I've done, I tend to use my own testing frameworks.
Mm-hmm. Okay. I hope Lucas, Brandon answered the question. So yes, for now we don't have any more questions from Discord, but I remind that every participant can write a question in the chat, and Brandon will answer them there. And I propose to continue the conversation in Discord. Oh, actually, yeah, thanks, Lucas, texting, thanks. So, Brandon, thank you so much for joining us today, and I wish you a good day ahead, and hope to see you at the next Fwdays events.
Thank you very much. Thank you.